Hello guys, welcome to my channel Science Classes by Malik. Today's practical is to convert a given galvanometer of known resistance and figure of merit into a voltmeter of given range, that is 0 to 3 volt, and to verify the same. As we know, galvanometer is a device which is used to detect or measure very small amount of current, and voltmeter is a device which is used to measure the potential difference between two terminals of a cell. But in this experiment I can teach you that how can a galvanometer work as an voltmeter. Apparatus and materials required: a galvanometer of known resistance and figure of merit, voltmeter of given range, a battery, resistance box, rheostat, key, connecting wire, and a piece of sandpaper. I can show you the connections. Firstly, I can show you the devices. This is battery eliminator, this is galvanometer, this is voltmeter, high resistance box, rheostat, key. These are total devices that is helpful in converting a galvanometer into a voltmeter. As we know, whenever we connect galvanometer with the high resistance, then the galvanometer and high resistance box mix together and work as an voltmeter. Alone galvanometer cannot be work as a voltmeter. It can be only possible with the help of voltmeter. Now let us see the connections. Here is the battery, and the positive terminal of the battery is connected to positive of galvanometer. As you can see, positive terminal of the battery is connected to the positive of galvanometer. Next one, galvanometers same terminal, that is positive terminal, is connected to positive of voltmeter. As you can see, galvanometer positive terminal is connected to the positive of the voltmeter. Now galvanometer's positive terminal is also connected to rheostat. Galvanometer positive terminal, this wire, is also connected to the rheostat, and voltmeter's negative terminal is connected to high resistance box. Voltmeter negative terminal is connected to that high resistance box, and high resistance box, this terminal, that is this terminal, is connected to the negative of galvanometer. This is connected to the negative, this wire, negative of galvanometer, this one. This is the wire, this is the wire, this is the wire, this is the wire. Next one, battery's positive terminal, rheostat, galvanometer. Rheostat's terminal, this one. Rheostat terminal is connected to the key. Rheostat terminal is connected to the key, and the other end of the key is connected to negative of the battery. Other end of the key is connected to the negative of battery. Here are the all connections in this diagram. Now I can switch on our device. As you can see that now we can see the calculations. EMF of cell is 3 volt. This is fixed. Resistance of galvanometer is 192.3 ohm. This is known. We already calculated in the previous experiment to measure resistance of galvanometer and figure of merit by half deflection method. Figure of merit is also given. It is 2.65 into 10 to power minus 5. I can show you. I already measured and right behind the galvanometer. This is 192 ohm and this one is 2.65 into 10 to power minus 5 ohm. And capital N is number of divisions in the galvanometer. As you can see in the galvanometer, 30 is the maximum deflection. And the current for full scale deflection is I small g equals to nk. N is given and k is given. Galvanometer that is converted into voltmeter is of the range 0 to 3 volt. Now we know a high resistance is connected in series with the galvanometer. What is the value of this resistance? That can be measured with the formula V upon Ig minus G. V is maximum volt, 3 volt. Ig is this. Capital G is also known. And we calculate resistance, that is shunt resistance, 3581.2128 ohm. Now I can show you in the resistance box 3581 ohm, 2000 plus 1000, 3000, 3500, 3550, 3570, 3580 and 3581. This high resistance I applied to the resistance box and which is connected in series. That is, resistance box is connected in series with that galvanometer. Now least count of voltmeter. What is this least count? Least count means the smallest value that can be measured with the help of galvanometer. This is 3 upon 30, that is 0.1. Now I can show you the readings. I can on the plug and the light glows. Now I can show you galvanometer and voltmeter with the help of rheostat. You can see both galvanometer and voltmeter are moving as I move the rheostat. Now see, this least count is 0.1. Now we can verify. You can see voltmeter reading 0.35 when the division is 5. Now I can show you 5 in the galvanometer. I can show you 5. This is the 5. This is the 5 in the galvanometer, and the reading on the voltmeter is 0.35 volt. When the number of division is 5, voltmeter shows 0.35 volt. 0.35 volt at 5 division, and 5 into least count is 0.5 volt. Voltmeter measures the voltage 0.35 volt, and our galvanometer, which is converted into voltmeter, shows the reading of voltage is 0.5 volt. That means error of 0.515 volt. Similarly, when I take the galvanometer towards 10 with the help of rheostat towards 10 with the help of rheostat. This is the 10. You can see 0.65 volt or 0.7 volt, exactly 0.7 volt. But in this case 0.65 volt. Here is our previous reading. 0.1 into 10 is 1 volt. This is the reading that galvanometer shows. 10, that is deflection in galvanometer, and 0.1 is least count. So 1 volt is the reading that galvanometer shows, and the voltmeter reading is around 0.7 volt. Here is the error 0.3 volt, but in this page error is 0.35 volt. So it's verify of conversion of galvanometer into voltmeter with the error 0.15 volt and 0.35 volt.